So I was saying that there's a 4th Street here, and there's a 5th Street here, and then there is a main road huku, and the main road upper ni 1, and here 1.1.1.1. So if this one, there's a packet that is coming from that house, say for instance this house is .5, and then this packet is coming here to .20. So when you leave this, you come here, you pass through this. In fact, your router on your side, will say, oh, then you say, okay, I'm going to 192.168.5.20. So this router will say, oh, okay, usaende ukusaidi yai yenda uku. Ndiye chito routing, it will say nimuziba wameo kamba, niziba network wamene iri pass so. So go. Then you get here. Then when you get to this router here, this router will open your packet, which is coming from your house here. It will open the packet and say, oh, okay, yeah. In address yet 192. Remember this one address me. It will say, this address, I know it. I know this address. This is our address, yes. But now, which house? Then you say, okay, house number 20. Then it will say, okay, new. Then you come back, you come down. So that's what I mean by last point, saying that first, when a packet is received on a router, the receiving router, the destination IP address is checked. And then if the packet is not destined for that particular router, because the router has its number, it knows this number, it will look up the destination network address in the routing, which means this router which is on the receiving end here, when yours has already passed to this one. So it will say, this one, it's not my address. And then it will say, this address, okay, we end up. That is if it's supposed to go. Now, then point number 3, once the router chooses an exit interface, the packet will be sent to that interface to be framed. Now, what does it mean to be framed? Say, for instance, if this packet has been received correctly on this, and remember, we are dealing with layer 3, and on layer 3, the data items are called the packets. But if a packet is to be delivered to a house, of course, it has to also involve layer 2. Layer 2 has to be involved as well, because layer 2 ndiye wama MAC addresses, and I told you that MAC addresses are the like fingerprints of a computer, and the data at layer 3 is called the MAC. It's called the frame, not it's called the frame. Data, those data thing, they are called the frames. So which means when it is received here and is going to be passed down to a recipient, it must be decapsulated. Okay, the language of decapsulation, I will talk about it. Encapsulate means put in an envelope. Decapsulate means remove the envelope. So which means if it is destined for this place, then it will say, okay, we already know that IP address. Okay, now tieti chose mukati tiyanganisise ngati ni okay, say for instance the recipient house was 192.168.1.5.20. It has to counter check. Okay, this one, yes, we have it. But let's counter check. Nga MAC address ni ndani. But you must know that MAC address represents like your name, your individual name. Something that uniquely identifies you, your name in your house. So it will say, okay, yes, talandira inkalatya nyamuno mu compound, but manje ni ndani zina muntu uyu. So it will remove the envelope ya layer 3. So that's what we mean by framed. So that it becomes a frame. Because at layer 2, once you remove the envelope, kusala data ya layer 2. Because ya layer 3 waichosa envelope. Manje kusala envelope ya layer 2. And that envelope ya layer 2 is called a frame. So that's what we mean here, that once the router chooses an exit, the packet will be sent to that particular interface to be framed and sent out to the local network. Okay, if the router cannot find an entry for the packet destination, then what will happen? The router will destroy it, will damage it. That's what we mean by dropping it. Will just damage it, throw it away. So that is about this. Now, the device which works at this layer is router, and the router is a layer 3 network. Now, there's something that we must understand about this, that a router breaks the broadcast domain. Last time I talked about it, that in a local area network, Kulima computers, there are a lot of computers inside there in this local area network. All these computers here, they are in the same broadcast domain, meaning that if this network had 192.168.4.x, okay, instead of x, let me put 0. 0, we don't use the word, we don't use x, but instead we use 0. 0 to represent 1, to represent 2, to represent 3. You know, it's like an empty space there. You can put the appropriate numbers. So this is the network. So now we know that a computer that wants to talk to all these computers on this network, there is an IP, a special IP address it uses to talk to all of them. What is that special IP address? If you have forgotten, then I'll be upset with you. Tell me.
Broadcast address.
What's a broadcast IP address?
255.
255 is something else. What's a broadcast? And we even demonstrated. What's a broadcast IP address for this network? No one wants to answer. Huh?
Is it not 255?
It does not start with 255. 255 is subnet mask. That IP address, I even demonstrated it.
Is it true?
Right.
Okay, somebody was talking about 255. Maybe I broke them earlier. But what you said has truth. Maybe just give more details. There's a 255 somewhere, but now just give more details.
Or maybe like the one you wrote here on the screen, which is 192.168.43.255.
This is the broadcast. Very correct. This is the broadcast.
Oh, good.
This is the broadcast IP address. Thank you very much, ma'am. That's a broadcast IP address. This 255 class cannot be given to a single computer, because if you want to broadcast to all the computers, you use 255. So a computer, a computer which is going to talk to all these computers in this network, it has to use 255 to communicate to all those computers in this network. It has to use 255 to communicate to all. Now here is a network. Okay, let me clear this screen. Here is a network here with all the computers inside there, all the computers. And here is another network with all the computers there. And then there is a router there, and there's a router which will communicate. The router makes sure that all the broadcasts remain in a network like that. And also this router makes sure that all the broadcasts remain in there. So the broadcast, the noise inside here cannot go there, no. And also the noise here cannot go there, no. So therefore, one of the biggest strengths, one of the biggest beautiful thing about a router is that it breaks the broadcast domain. It breaks the broadcast domain. So much that, which means that by default, broadcasts are not pushed to another route. They remain behind the route. They remain behind the route. When number two there, bullet number 2, they also break what is called the collision domain. This network here, more especially if these computers are connected to a hub. These computers are connected to a hub. There's a topic on this one later on. I will explain more. If all these computers are connected to this, which means there will be a lot of collision. There will be collision. This computer is trying to send there. This other one also, they bunkana. There will be collision. And if here there is a router, all the collisions will remain behind the router. They cannot go outside. Please, here I'm talking about where you have used a hub. But when you use a switch, you will see it will be a different ballgame. Let me just show you. I don't want to explain more because I have a topic on that one later on here. This topic here, I go into the depth to explain the collisions. The collisions, I have explained all this. That's why I said that these notes are more improved. So I will explain all these things, the collisions things. So for now, this is just an introduction to where we are going to. So then the bullet number 3, it must, each network is given a unique network identification number. Do you remember I was saying, let me bring back the streets. In 4th Street, which means 4th Street, the IP, the unique network identification number will be 192.168.4.0. I've already told you why I'm putting 0. If this is the 5th Street, this will be 192.168.5.0. So EE, a unique number for this local area network. This one is a unique number for that local area network. So that's what we mean. So you check here. You can see on this second slide that I have here a unique identifier. Here I have a unique identifier. Here I have every after a router. Ukachekoche per router. Even here, once you choka router, kuli network identification number. So we can see that here kuli unique na papali, and here and there, here and there. Anywhere where there is a router, mukachokache router, there is an IP address. Also, this other side of the router, once you move, it has also another IP address, another network identification ID, and they are all ending with 0. Why are they ending with 0? I've already explained. That 0 is like a placeholder, like X, so much that in that 0, we can put 1, we can put 2, so just like that. Then here, this one as a network and this one as a network. We can see that there is a router. This router, what does it do on top? It will keep the broadcast domain here, and it will also keep the domain, the collision domain here. Similarly here, it will also do those two functions. So the router's job is to break a broadcast domain so much that broadcasts cannot go outside to the other network. They can't. They stay inside. And also bunkana kuja ma accidents or bunkana, they also stay within the network. They cannot come outside here to go and bunkana out there, because if they go about bunkana, which means the whole network on planet Earth will become extremely very slow, because a lot of packets will be lost, a lot of packets will be colliding each other, and then also there will be a lot of broadcasts. And therefore, with the broadcast, which means it's just like, for instance, you go to these markets. Each one say, each one is, and this other one is playing music. This other, like for instance, if you go Comesa Market, I don't know whether it's Comesa. When you go there, this one is music here, the other one music there. There's just collision of music. That's what we mean by collision domain. City Market, yes. There's too much noise, and everyone, this one is talking, this one. There's just noise. That is collision domain. Now, think of it, if the whole world was like that, the whole planet Earth, there was noise, would have been bad. So the same, so therefore, noise in Karamu, noise stays there, doesn't go out. Okay. Okay, then the next one there is here, layer 2. We come to layer 2. We are done with layer 3. Layer 2, this provides the, now listen, layer 2, what does it do particularly? Each computer on layer 2 has a MAC address. Each computer in that particular network has a MAC address. Now, what is a MAC address? A MAC address is the individual name of a computer. Like for instance, if this is the street, kuli house up, and inside those houses, kuli bantu, my individuals mukati munyumba. Because now, look at it and listen carefully. A packet can come to this house. If this house was .9, it will mean that it will be like 192.168. Say for instance, if this one was okay, .5.9. But munyumba inyumba sikunkala muntu mozi mankala na bantu bambiri mukati. So So a packet must therefore come and then uniquely identify individual person inside. So the MAC address is like the individual. Network will look for the location. Network looks for your location. Pame unkara muchikomboni na panyumba pamene unkara. But inside that house, there's you yourself. If you are Mr. Alfred Bill, therefore, in this situation, MAC address is Alfred Bill, your name, which uniquely identifies you. So, therefore, my MAC address is in Chito yayo. It is to uniquely identify you from your location. Please take note. IP addresses, layer 4, layer 3 rather, ni my location. Then MAC, which is at layer 3, ni individual person, individual work as an entity to individually identify you using a MAC address. Okay, let's read. This layer provides for the physical transmission of data and handles errors in notification, network topology, and flow control. The other thing it does, it ensures that messages are delivered to the proper device, proper on the local area network. Now remember that local area network ni muja mu street muja. Muna manyumbas, muna ma houses. Ija street. But in the street mukati muja kuli bantu. So then that's what's going on. So ensures that messages are delivered to the proper device on the local area using the MAC address. That MAC address is also called hardware address. And will transmit messages from this layer, from the network layer. Oh, sorry, translate, not transmit. Translate messages from the network layer into bits, which means network layer is layer number 3, the network layer, and here these are packets. The zine. For layer 3, for layer 2, these are frames. Then layer 1, these are bits. So that's what we mean. That layer is atenga information iri pamwamba. Ma packets is atenga ma packets no achinja kunkala ma bits. So it is the responsibility of this layer to translate the packets or frames into bits. So then the layer format or the message itself at this is called data frame. And when a data frame is created, some information is added to the header. What is put in the header when an information like this is created? We'll be looking at all these things later on as we go on. There's this header. In the header here, information is put about the MAC address. And what information is put here? The destination MAC address and the source MAC address is put. That is the information which is put. So this added information forms what is called the encapsulation. Encapsulation. We'll be looking at all these things later on. There's a topic as we go on, which looks at such things. It is here. This is the topic which will look at all those things. You can see here segment, packets, frame, bits. You can show that. So we'll come to that and look at them in details separately. But for now, just know that there's stuff like that coming as we go on. So this is what goes on at layer 3. Then, okay, I want you to know also that communication within a local area network is more of by MAC addresses. More of by MAC addresses. What do we mean? These are houses here. These are houses here. So when I want to communicate to somebody here, I call them by name. John, Bunch. You know, you are in the same place. You are in the same local area. So therefore, communication here is more of by MAC addresses. MAC addresses, I told you, like they are like your name, your name, your name. But if I'm going to communicate to another local area network there, then I must use layer 3. But within here, they use layer 2 and they communicate using my MAC addresses. But if I'm going to communicate to this other one, then I should use layer 3, which means there should be a router, and this side there should be a router. So basically, when you are communicating from one local area network to another local area network, you use layer 3 because you need a machine which does routing. But if you are going to communicate within the local area network, you are going to use my MAC addresses, more of my MAC. Of course, IP addresses will be used, but there's more of MAC addresses that are used than my IP addresses. So let's take note of that. So I think I've already explained all this information, which you can read because I've already explained it. Now let's look at the devices that are found at layer 2. Layer 2 devices will switch number bridges. Switches, number bridges. I already told you that a switch is just this big machine, and this is switch with a big machine in at my hose with all these holes, we call them ports, and then you connect a computer to it, and then you connect another computer to it. So it's like an adapter like. So a switch is found at layer 2. A switch is found at layer 2. Now, you can also find in other networks a hub. You can also find a hub in some other networks. But there's a difference between a hub and a switch. Difference in kuru maningi pali hub na switch. Now, the appearance of a hub and the appearance of a switch vioneka same. Same we are same. Same, no difference. They will all have many ports. I think we already saw them on internet, so there's no need of me opening there unless you want to. Should I open, or you already know them? Yeah.
Open them.
Can open.
Okay, my switch amaoneka so. Switch, oops, no, network switch. Let me network. Network switch. Dear, my network switches are. Dear, my network switches are. They have a lot of ports. And also my hubs never oneka so. Exact. But no, please, that my hubs ni old technology. New technology is switches. So if somebody comes to your school and say, I'm glissaring a port, a hub, please take charge. You are now informed. Don't buy a hub. Tell that person that I know that we no longer use my hub. You just want to make money. I remember there's some guy who came to our school. I was still in secondary school. He came and was selling his switches, my hubs. And then somebody almost bought from my school. Then when I got to know it, because at some point they had to consult me. They're almost paying. And then somebody had to consult me. Maybe let's come and buy first of all. Then I looked at it and said, no, you can't buy these things. Okay, now, I'm saying you can't buy these things. But I've not explained why. Okay, I want to explain why we cannot buy Mahabs anymore. First of all, before I even go further, what is a switch? Bridge. Bridge. It's also similar to a switch. The difference is that ichabe na tumapoti tungati or 3-4 in this situation. Have you seen that one? That is the only difference. Why do they have 2? Bridge. Bridge is a bridge. Like there's a river here, and then you put a bridge. Meaning that, what is the job of a bridge? The job of a bridge is kuli network. Let me show you this one. That's the way they did this. I think this one is better, like this one. There is ukukuli network, local area network. Now kukuli local area network. Kuli na switch, now kuli switch. So you want to connect these two. You want to bridge them. You want to bring them together. Say for instance, maybe in hostel number chakutuko nenangu ni hostel number 2, hostel number 1. Now you want to bridge them, to connect them together, make them one. You don't have to buy a switch, because a switch in a mapoti ambira so idura. So instead you buy a bridge, because a bridge in a mapoti ya ngon, like you can see on this one. Kuriche mapoti are 4, meaning that you can connect it. You can even just use the 2 of them. One to go this other direction, the other one to go the other direction. That's all. That's all. That's the job of a bridge. I hope it's clear. So they will do the same job, except the difference is that a switch has more ports. Like this one, it has more ports. A bridge has only 2 ports. So this is a bridge, and this is a switch. But there are some switches also that have my bridges, my ports, they are there. So don't be surprised when you see that you have a lot of. Okay, fine. So now the beautiful thing about a switch or a bridge is that when you communicate, say for instance, there's a switch here, it's connected. This computer is connected. And then there's another computer there, it's connected here. Now, the MAC address for this computer, once it communicates using this port here, port number 2, and this one, port number 1, it communicates to this one. This gadget, it will store a record that port number 1 could MAC address, okay, let me say XX, then X, this XY. So it will say per port number 1 could XY. Per port number 2 could, port number 1 could XX. Port number 2 could XY. It will keep that record. So much that whoever, if there is a computer somewhere here, it wants to communicate to this computer there. This switch will not broadcast here that word. It will not broadcast the messages to all the computers on the network. It will instead deliver to this port and say, I already know where this guy is. It's just like, for instance, okay, let me put it this way. The best example that I always give between the difference between a hub and a switch is this. You go to a classroom, you find students. This guy is the office order, and this other guy also is office order. One office order is smarter than the other one. So abadebe bahab bakapayam class. Every time he comes to the same class, say, who is Alfred Pill? And then Alfred Pill raises up and then he goes delivers. Again, he receives another letter. He comes back, who is Alfred Pill? And then Mr. Alfred Pill raises his hand, and then he goes and delivers. And then later on, Mr. Alfred Pill receives another letter. He comes, who is Mr. Alfred Pill? He will never know where, he will never memorize the desk where Mr. Pill is. The problem never happened. But if I switch, baby, they will come only once and say, who is Mr. Alfred Pill? Then he knows, okay, Mr. Alfred Pill is on page, desk number 4. So the next time he receives, just goes to desk number 2 for receives, delivers. Next time another message comes, just goes. So which means this switch memorizes the MAC address of your computer, and it also memorizes the exact port. Cable direct is so it will just go to cable, to port from the port computer without disturbing others. So therefore, that's what we mean here. That's what we mean, that the switches are both work at this layer and filter the network using MAC address. Filters, which means it doesn't like broadcast, just it filters, just like it goes direct and delivers to correct destination without disturbing others. Then switches read each frame as it passes through the network. The switches, which means there are 3, then put the source hardware address in a table and keep track of all the ports. So you see, that's what I just explained. So this information, which is logged, is what helps the machine determine the location of a specific sending and receiving device. We'll end here. Tomorrow I'll give you this diagram, which I've already explained. Tomorrow I'll pick up from here. So you can see this is the table which it keeps. And then I'll explain more tomorrow. Please, let's be punctual tomorrow. Let's be punctual. So I'll pick from this.
Tomorrow.
Come again?
Right.
Thank
you, sir. Good night.
Tomorrow.
Okay, thank you very much.
Okay, good night.
Good night.
Hi.